Welcome everyone to the day 14. In the today's video, we're going to talk about the important concept called as inheritance. And in the process, we talk about the concept like what is the significance of this and super in the world of Java. We also talk about the composition. So now let's get started and understand all these concepts in a hands-on way. It is again very important in the world of the OOPS concept, which is again the interviewer's favorite. And you use a lot of times in your programming. It's called as inheritance. And again, it is very much related to the real world. Right? Just to give you the real world examples. In the real world, normally what happens, whatever that your grandparents earn, eventually, that your parents will inherit. Right? Whatever the things that they made, they bought the land, they built a house, they made money, whatever it is, or the challenges or the loans, everything the parents will inherit. Whatever your parents will do, whatever the money that the parents will make or the challenges that they will have, you will have to anyway inherit. Right? And typically what you will do, your kids will have to. So the law of inheritance, right, is there in the real world also. Same thing I want to go and apply in the world of programming. So what kind of relationship it is? It is more of like a parent-child relationship, or I can also consider it's a hierarchical relationship. What kind of relationship it is? It is a hierarchical relationships. Layer wise, layer 1, layer 2, layer 3. So in the world of the programming, whenever I have to go make a parent-child relationship, hierarchical relationship, I go and make use of the concept called as the inheritance. Now if I have to go and apply the inheritance between the two classes, let's say that is the class C1 and the class C2. And I have to go and find some kind of relationship if there is a parent-child relationship happening between C1 and C2 itself. How can I do it? See, in the real world, if there are two persons, this is the person 1 and this is the person 2, and I have to go and check if person 1 is the child of the person 2, there is a medical test which you do that is called as the DNA test. Right? DNA testing is done to understand if the two people are related to each other in the parent-children way. Same way in the world of programming, if I have to go and say that C1 and C2, are they related in the form of the parent-child relationship? I have a DNA test in the world of programming which is called as is-a test. So when I go and say that between two classes, if I go and put a question, is C1 is a C2? There could be two outcomes. If the answer is yes, then I go and say that C1 is the child of C2. If the answer is no, then I go and say that C1 can't be C2. C1 and C2, there could be no inheritance. So again, I'm summarizing. Inheritance means that there is a parent-child relationship that I want to go and establish. And why I want to go and establish? So that few of the characteristics, the behaviors, the method, the state of the parent could go to the child itself. But before we maintain a parent-child relationship, we go and write the code for it. We have to go and do a test. If this is true, then it makes sense. Otherwise, it doesn't make sense. For example, if I have a class called as cat and I have a class called as animal, and I want to see that if the cat and animal can have the inheritance, I can just put a question called as is-a, and the answer is true, so I can go and say that animal could be the parent and the cat is the child. Fair enough? On the other hand, if I go and say that cat is another class called as machine, answer is false. So the answer is false. It means that I should not ideally, no one is stopping me, but ideally I should not go and put cat is a machine. I should not go and put the inheritance here. No inheritance. So now since we have understood that what is inheritance and when do we go and apply it, let's try to see that how we can go and do in the world of Java. So in the world of Java, we have already seen that there is a concept called as a class and the concept called as the interface. So at the parent level, you can either have a class or interface, and this could be a normal class or it could be an abstract. So one type is the class, another is the abstract class. So I have the class, an abstract class, and then I have an interface. Now this could be at the parent level. Right? And then I will have the child class. So if I'm trying to inherit from the child, from the normal class or abstract class, I use a keyword called as extend. Right? And use a keyword called as an extend. But if I'm trying to do the same thing from the interface, I use a keyword called as implements. Now in the world of Java has limited that you can only extend one class. In the world of Java, you can only extend one class, and I'm talking about only one class. Whereas in the case of the interface, you can have multiple interfaces. And then a very important interview question comes here, that why only one class is allowed and why the multiple interfaces is still fine in the world of Java. We'll talk about it, but first let's see this in action, that how this whole inheritance is working. And then we'll again come back to this question, that why multiple inheritance in Java, unlike other programming languages, why it is not supported in Java itself. So first of all, with the code example, let's try to understand how the inheritance works. So I go and open my Eclipse. And in the Eclipse, let me, since it is important, more classes will be involved, I'll go and create a package here, and let me go and create a package called as inheritance. Okay, that has been done. We'll be going to close all the files. Okay, and now here what we do is that we're going to create a new class, and let me go and call this class as the animal class. And this is my animal class, and this animal class, let me go and define a method called as public void eat, and call it sysout, and I'm going to say that animal is eating. And then I have another class, let me go and call this another class called as dog. Now if you're going to try to compare the animal and the dog, right? Now dog will also have to eat and animal also has to eat. Now if I try to go and put the is a test, right? If I go and try to do the is a test, and I go and put between dog and animal, if we go and put this is a keyword in between. When I go and put dog is an animal, what will the output? I get the output as true. It means that inheritance could be there. It means that dog can go and extend animal. So since animal is a proper class, what I can go and do here is that I can go and make use of the keyword called as extends. So I'll go and say that extends animal. Fair enough. And now the dog could have also one more method. For example, public void, and I will call it bark, and inside this I go and write this out, and I go and say the dog is barking. Fair enough. So I have this animal thing done, I have this dog thing done, and we're going to find one more class called as a test class or a zoo class. We're going to call it as zoo, and this has a method called as public static void main string args. Right, I go and save it, and here what I go and say that dog d equals to new dog. Fair enough, I'm able to create the dog. And then if I go and see this d dot, I will see that I have a method called as eat. If you try to go and see here inside the dog, I don't have any eat method. It is there in the animal, right? But still, when I go and run this code, it is printing animal is eating. How does it happening? So if I go and show you this inheritance, I have this animal, and then animal I am inheriting in the dog. Animal has this meat, animal has that method called as eat. So the dog is inheriting this dog object also. When I go and do this dog.eat, it is printing animal is eating. But can the reverse happen? Let's say that you have the hold in whatever your parent earns, but does the parent will also have the hold on what you earn over a period of time? No, right? So let's try to see that if that happens in the world of programming also. So if I know that the dog has a method, dog is barking, right? So I come back here and we're going to define instead of dog object, we're going to define an animal object, a equals to new animal. And let me go and try to call a method which is there in the dog. Let me go and call it a dot bark. If you see here, it is giving the compilation error. The point that is here, if there's a parent call as animal, and then there's a dog, and there is a, so everything which the animal has comes to the dog, but everything which dog has does not go to the animal. So the child will have the access to the parent methods fields, but the child will not have. Now another important concept I want you guys to be very clear here is around, so I have this animal, and then I have this dog. So when I go and initialize this dog, what will happen internally is that it will go and call the dog, right? When I go and define this, it will go and first go and call the animal constructor, and after that it will go and call the dog constructor. This is a very important sequence which I want you people to be aware of. Just to make sure that you are clear on this, let's try to go and define, say for example, let's say I'm here, and this default constructor, let me go and define this public animal, and I go and say that sys out animal constructor has been called, fair enough, and then I go and open my dog also. And here I go and say that public dog, and I go and say that sys out and dog constructor has been called. So when I go and run this, if I go and save this and open zoo.java, right, I'm just calling this one, right? And if I go and run this, what it is printing, it's first printing animal constructor and then dog constructor. So whenever you have a parent 1, parent 2, parent 3, and then let's say that this is final child. So if you're trying to create the object of this, let's say that you are saying that C equals to new C. So what will happen is it will try to go and call its this. So first of all, this constructor will be called. Then this constructor will be called, then this constructor will be called, and finally this constructor will be called. Please keep this in mind, the order in which the constructors are being called here. Fair? Now let's make this a little more complicated. Let's say that animal has few more additional fields. For example, animal has a field called as private string name. It is something private int age, and then this constructor that I have will require something called as a string name int age, and then I do here this dot name equals to name, and then I have this dot age equals to age. I know that as soon as I go and define user defined constructor, the default constructor will go away, right? So the default constructor is no more available now, right? So this works all fine. This is my dog.java. So in my dog.java now, it has started giving me the error. Why it has started giving the error? Because dog is extending animal, but the dog right now doesn't know how to call the animal constructor, right? And I know that if the dog has to be created, before dog creation, animal has to be created, because animal is parent. First the parent will come, then the child will come up. So I have to go and make changes in this doc itself, right? So I have to come here, right? Animal has these fields, name and the age. So I anyway have to go and provide the name and the age. So inside the dog also I'll have to go and take something called as a string name and int age. And then since I have to go and call the constructor of the parent class, we go and do it with the keyword called as super. We go and do it with the keyword called as a super, and then I go and pass name, and then I go and pass age. The super keyword that you see is actually very superb. It is used to reference the parent object. So this is used to go and call the parent constructor. Super is always the first line which gets executed inside your constructor. So be very careful about this keyword called as super. Super is a keyword which again is a very interview favorite for the interviewers. Let's talk a little bit about the super so that you are all guys are all set for the question if that arises on the super thing, right? So if I go and talk about the super, right? Super is normally used to reference the parent class or the object, right? And it could be used for three things. It could be used for calling the constructor, calling constructors. It could be used for something called as calling methods, and it could be used for the calling the parent field, calling parent fields. So super will be used for calling constructors, that's number one. It could be used for calling the methods, and it is used for calling the parent field. This is the whole use of the super. Let's try to quickly write a code and try to understand the uses of the super. So let me go and open my Eclipse, right? And let me go and define something called as new class. Let me go and call it as a parent class. And inside this parent class, let me go and define few fields. Let me go and define a field called as int value equals to 100, and then I have something called as a public parent, and I will just out parent. What do we go and call it as? We go and call it parent constructor. And let me go and define a method called as public void display, right? And we're going to call it sys out, and I'll go and say that parent is display. Okay. And let me go and define another class called as class child. Class child, and I go and say that extend parents. Yes, in the same Java file I can have the multiple classes, but only one class could be the public, which should be the name as the same as the parent class, parent.java. Now here in this case, right, what I can do is let me go and define another class. This is fine, okay. And in this child class, what I can go and do is I can go and say that int value is equal to 200, and then I can have the same method public void, and I'll also the display, and then I can go and call the parent display method by using something called as super dot display. So this will display parent method, right? And then I have something called as public This is fine, right? Let me go and define the constructor of this public child, and inside this I have to go and first call the parent, right? So it should be like super, and then I got this is out, and again so the child constructor. And inside this, let's say that if I go and want to print this value of value sys out, this dot value, and then I have sys out, I'll go and say super dot value. So you see here on the screen right now, correct. So I have both the child and the parent. Let me go and open my desk scribble. You see here, this is my parent, this is my child, child extends parents, correct. So using the super, I am trying to parent constructor. Using the super here, I am going to win the parent value, and using the super dot display, I am able to get the parent method. So these are the use cases of super. So again, this is one of the very important questions that people do ask in the interview. Just I wanted to make sure that you are aware of the keyword call as super. And with that, there is one more question where people will ask you that what is the difference between super versus this. Very simple. Super is normally used for the parent object. It's used for the parent object or instance. And whenever you go and create if there is an inheritance and there is a child object or instance, the parent object will anyway get created. This is mostly used for the current instance. Fair enough. So we have understood the first type of the relationship, which is the parent-child of relationship, which we go and do with the help of inheritance. But in the real world, that is not the only type of the relationship. There's another type of the relationship which is there in the world of the programming, and that typically is called as has a relationship, a kind of relationship which involves possession, right? And that is technically being called in the world of the programming, the world of Java, as composition. Let's try to understand what is that. Say for example, there is a class called as person and there is a class called as car. Now I want to go and represent if the person can possess car or not, and for that we set up a question called as has a. If the answer is here true, then I say that okay, the person can possess the car. If the answer is true, I cannot allow to do that, right? So has a is another type of a test which tries to see that if something can be possessed inside the another, and that we do with the help of composition. Now how it is being done, let's quickly see that with the help of the code itself. So if I go and define something called as Eclipse, let me go and open it. And here let me go and define first of all a class called as car, and the car has some fields, for example private name, private color, and I have to provide the type also, so it has to be string, and then I have to go and provide the color, which again has to be the string, and then I have to go and say that manufacturer, and I'm going to call it as that also as a string. So I go and select on this, click on the right, click on the source, and then I click on the create getters and the setters. I'll go and select all this and then click on the generate, and I see that my getters and setters has been created. Now let me go and rearrange this to bring it this. Fair enough. So this is a by car class, right? Then similarly, let me go and create another class called as person, right? And this person class, what I'm going to do this, I'm going to find something called as private car, and then I'm going to car. So if you see here inside this person class, right? Inside this person, I have composed car. This is called as composition. So we understand by now that in order to go and find the relationship between the two objects, in order to go and find the relationship between the objects, relationship between objects, we know that it could be done in two ways. What are those two ways? One of the ways is inheritance. And the other way is that through the composition. Now this is again a very common question being asked in the interviews, that then okay, both are being used for the relationship itself, which is doing what and what is the difference? So quickly, if you go and see that inheritance is applied when there is a kind of a relationship. Composition is applied when there is a has a kind of relationship. That's number one. When you go and make an inheritance, it's a maybe more of like a parent-child relationship. It's more of like a parent-child relationship. When you go and more of like a composition, it's more of like a possession type of relationship, that I hold something, possession type of relationship. Now since it's a parent-child relationship, it's more of like a tightly coupled. Composition, contrary to that, is loosely coupled. And since it is tightly coupled, so it is less flexible. And since it is loosely coupled, so it is more flexible. So these are the differences between the inheritance and composition. We have already covered almost all the types of object-oriented principles. We started with the class, we talked about the object, we talked about abstraction, we talked about encapsulation, we talked about inheritance, we talked about the composition. Now one and the most important and the interview favorite, as I say that, this topic itself is interview topic. There's so many topics which could be asked in the interviews, is called as polymorphism. So finally, we have come to the end of this video. It's day 14 and today we talked about inheritance. We saw that just in the real world how the inheritance works. In the world of programming also, you can have the parent-child relationship. We talked about is a relationship, which is inheritance. And then we also talk about another type of relationship, which is a has-a relationship, which we talked about in the company. If you are loving the journey, please let me know in the comments, share with your friends, because your small efforts of sharing this content, liking it, putting up the comments, give me the enough kick to go and bring more content for you people live, to bring more content free for you on YouTube. Keep learning.